So, hello everybody again. Here we are on the episode number 4. We now use the Logic Volume Manager, and now we come to the interesting part, because now we can use the LVM to actually increase the size or even move the blocks. So this is our current situation. Remember last time we've mounted our Logic Volume. It's still in place. So let's have a look here. So we have this data directory with the Logic Volume, and this is mounted in this data directory. LV display gives us a list of the size of the current Logic Volume. And now the important thing is, because this LVM gives us much more flexibility compared to the basic partition table, we can now come to the idea to enlarge the size of the volume. The big advantage is here, you can do this online. You don't have to unmount this thing first, or even reboot the entire machine. You can do this as long as the same time as your employees are working with the machine. So no need to unmount or reboot anything. This is one of the big advantages, of course. So now let's assume now we have 200 megabytes. Now let's assume we want to increase the size a little bit by another, let's say 300 or 250 megabytes. So the only command, or actually we need two commands. First of all, of course, we need to extend the size actually of this Logic Volume. So the command is lv extend, Logic Volume extend. So we simply extend the size. We say okay, size. We say okay, plus. So remember the total size is 500 megabytes. We normally can't use the entire size because something is reserved. So let's add 250 megabytes for now. And the name is dev, the same name, volume group 0 and LV0. This adds another 250 megabytes to this existing volume, to this one. So it's now successfully resized. Now let's have a look again with the display command. Now you see the new size is 452 megabytes. It actually has increased the size of the Logic Volume, while we still work on with this machine. No unmount operation necessary. There's only a small problem when we do this dfh command again. df-h command. You see it still says available 158 megabytes. So the newly added 250 megabytes are not available yet. And why is this? What we did with LV extend, we simply added more blocks at the end of our Logic Volume, but we did not inform the file system to actually grab the new blocks. It still thinks about that it can use only the old blocks. And now we need to resize the file system on this Logic Volume, which means we tell the file system, please grab all the new blocks and integrate this into the file system. Again, this can be done online. The command is called fsrdm resize. And then the name of the block device, oh sorry, not this one. The name of the block device, this name. And then it's resizing this image in this file system. You see now online resizing required. And now again we do this dfh command. And now you see it has a new size, and now we have 291 megabytes available. Again, remember this thing is still mounted. We didn't do any unmount operation. So we simply see our files, and of course we can get the files. So nothing has changed. The user can go on working with this same setup. So sometimes they see a little bit more space on it. And this is one of the big advantages. This is why it simply is better for managing, because there's no downtime at all. You can do this, can do everything online. So now let's go to the next step. Now we need more space, of course. It's always the problem. We need more space all the time. The problem is if we need to add another couple of 100 megabytes, then it's not possible anymore, because now the entire disk is in use. Of course, probably not the entire disk, but most of the blocks. Let's have a look on PV display. what did we use? So we have allocated 131, so only 11s are free. Let's assume we want to add another 200 and 300 megabytes. It's not available anymore for the physical extents of this physical device, but what we can do is we can add another disk and add the second disk again to our logical volume, or to the volume group. So this is what we want to do now. This was the first place. We have this SDB1, and now we add another disk, called an SDC. Oh, sorry, it's SDC1, not SDC2. SDC1, and then we use the P8 blocks from the second disk to be part of the same logical volume. By the way, this is called disk striping, which is okay if you want to extend the space, but this is bad from the security point of view, or from the consisting point of view, because when one of the disks fails, everything is gone. This is not good for availability, but this is okay to extend the disk a little bit. So this is now what we want to do. So what we need to do is first bring in another physical disk first, because we want to create another physical volume out of it. So for this I go to my PowerShell again. Remember, this is how we created a new virtual disk. I actually do exactly the same. I create a new disk, of course only by a new name. I name this disk 2. This creates a new disk. Then I add this new disk to the same virtual machine, same command as before. Disk 2. And now it's attached. So that's as easy as that. And now we should see another physical disk in our virtual machine. Go back to my virtual machine. Remember, we use this parted command, parted-l. And now you see another disk. So this is my default operating system disk. This is the disk for my physical volume. And this is this now newly added disk. Now it's named SDC for this third disk. And now the steps are exactly the same. We create a label, a partition, we create a physical volume, and then we add it to the volume group, and then we can span two disks for the logical volume. So let's do this. First of all, I use parted to create a partition. Parted/def. Again, be careful about using the correct name. SDC. This is the new disk SDC. Then I use mklabel, GUID partition table. I use mkpart to create a new partition. From name doesn't care, start bis 100%. I ignore this arrow, and here we are. We have this SDC1 partition. So now we have this SDC1 partition, and then we can add this. First we create a physical volume, and then we can add this to our volume group. So first of all, we do a pv create, physical volume create from this def SDC1. This is not SDC2 as in my slide, so this is called SDC1, of course. So this creates a new physical volume from partition 1 of SDC drive. Created. PV display. It's always a good idea to have a look at what has happened. And now we see we have two physical volumes. This is the old one, which is most of the P's are in use, and this is the newly created. It's not allocated yet because it's not part of the volume group yet. This is why we see a 0 there. That's perfectly okay. And now we bring in this new physical volume into our volume group, that we can actually use it. And the command is volume group extend. So we extend the volume group with another physical volume. Of course, we need to provide the name of the volume group and then the new physical volume, this one. And now it simply extended the volume. Now let's do PV display again. And now you see a difference. Again, this is the old one and this is the new one. Now we have a new 124 physical extents, and everything is free because it's not assigned yet. Okay, so this is now part of the volume group, and now let's have a look at the volume group display itself. Now you see we have now more free PEs from the second disk. So these are allocated, and these are the free PEs, spending 11 from the old one and 120. So we have this is what is free, the 11 from the first disk and the PEs from the new disk. And now we are ready to go to extend it to span 2 disks from our logical volume. So we simply can extend this again. LLV extend, logical volume extend, size, let's say let's try if we get another 500 megabytes from def volume group 0, LV 0. So now it has resized the volume, the logic volume. LLV display to have a look at it. Now we have a total not very close to 1 gigabyte, not exactly. So this is the new LV size. Of course, again, the file system does not have any idea yet. So when I do a DFH, it still says, okay, the total size is 400 megabytes. Now we have again resized the file system to make the new blocks available with the fs8m command. Where's this thing command? fs8m, here it is the resize command. So we resize this logic volume again. Again, do the dfh command, and then we see a change. Now we see this is the new size, this is used, and this is now available. So now we have we enlarged the file system, and now this 853 megabytes now it's spanned both of the disks. So this is called disk striping. First part of the file system is on the first disk, while the second part of the file system is on the second disk. Of course, this is a little bit dangerous because when one of the disks fails, everything is gone. No redundancy yet. Redundancy is part of the RAID part, which is one of the next episodes. So this is, but that's the idea about how to actually extend an existing space. If you run out of space, plug in a new disk, and then you can bring in more space. Of course, that's a little bit bad because when one of the disks fails, everything is gone. So the better idea would be to plug in a bigger hard drive and then copy everything from the old drive to the new drive. That's, by the way, the same case if one of the disks might fail in the near future. Most of the modern disk has a so-called smart interface, which reads the error rate on the disk, and when the disk tells us, okay, I will be damaged in the next 2 weeks, and this is not a joke, this is really working, so then you should take this really seriously and try to bring in a new fresh disk and then copy all the data from the old drives to the new drives. And again, the very big advantage of this LVM, you can do this online. I didn't do any on-mount operation yet because the file system is still in place. So we still have the file, everything is working, data and our test file. So the users don't care about this operation, but now what I want to do is I want to bring in a new drive. Let's again have a look at my slides. Where are my slides? So just a second, please. So now this is what I want to do right now. We had these 2 disks, and now let's assume I want to get rid of the older disk and replace this with a bigger disk. So now I bring in a new disk which is bigger than the old ones, and then I want to copy everything from both of the old disks to the bigger new disk. So this is a very common use case scenario. You plug in a new hard drive and you want to copy everything from the old disks to the new disks. And again, the big advantage is you can actually do this online without any unmount operation. So let's try to do exactly this scenario. Copy the old disks to the new disk. How is this working? Again, we start by bringing in a new hard drive, so the bigger disk. So I can go to PowerShell and create a new hard drive. Add new hard drive. In this case, of course, a bigger size. It is not 500 megabytes, I use 2 gigabytes to have enough space. Remember, this doesn't care about the actual size because this is thin provisioned. We don't waste any space on our physical hard drive. Oops, Okay, sorry. Have to use a new name, of course, because it still exists, this thing. Disk number 3. Okay, now created a new hard drive. And again, I have to attach this thing to my virtual machine. Of course, replace with the new name. And here we are, we have a new disk in our virtual machine. Go to Linux. And again, let's inspect the settings with parted. Parted-L. And you see now again a new disk. It's now called SDD. This is the error because it's an unknown label. The rest is still in place, the same as before. And now the same step as before. So let's partition this thing, create a physical volume, add it to the volume group. These are the same commands as we just saw in the previous example. Okay, let's bring this in. Parted/dev/sdd, the full new disk. mk label, GUID partition table, mk partition, name, type doesn't care, we start with 0, we go to 100%, 100%, ignore this error, and that's it, we quit. And then we have a look with -L, and now we see SDD, actually SDD1, this is our new partition. And then I again bring this new partition into the volume group, and then the basic idea is then we can move the data later. That's the big advantage. So now I've added this to the volume group first. So I need to extend the volume group by adding this new volume to our machine. So volume group extend. The name was volume group 0 and the new name is dev SDD1. Sorry, no, I forgot. I have to create a physical volume first. Sorry. Physical volume create first, of course, with /dev/sdd1. Physical volume create. Create it. And then extend this, I add this to the volume group. Volume group extend. I bring this into the volume group, dev SDD1. Sorry, I forgot the name. I need to extend the volume group 0, of course. Volume group 0. Okay, that's better. So now again, let's have a look at our settings. Physical volume display. Now we have 3 physical volumes here. This was our first disk. Everything is in use, no free PEs anymore. The second has still 10 PEs available, while of course the newly disk has all PEs available. So this is the current situation. So remember, our data lives on this partition and on this partition, but nothing is on this thing yet. In order to give us an idea where our data is actually located, we can do a LV display with the maps option. Logical volume display --maps. This is a good overview that we see where is our data, in which of the disks is our data. So here we are, this is the logic volume with our size of very close to 1 GB, and this is the mapping. So the first part of this logic volume is mapped on the first disk, SDB1, and the second is on SDZ1. Nothing on SDD yet, because we simply our new disk. And now what we want to do is we want to move all the blocks from SDB1 to this newly created disk SDD1. Because remember, we want to replace the 2 old disks with a bigger new disk. So let's initiate the move operation. And again, this is online. I still using my file all the time. Remember, the user is still working with their files. Nothing changed there. PV move, physical volume on that mode move. PV move. I use this -v option to see what's going on. And then you simply can decide, okay, I want to move everything from SDB1 to SDD1. This means please move all the physical extents from this disk to the other disk. So this now starts the move operation. Of course, this moves all the blocks from old disk to the new disk. Of course, this operation can take a lot of time. We only have 500 megabytes with a thin provision disk, which is quite fast. But in reality, this operation normally takes a couple of hours, of course, depending on the size of your disks. But again, this is online, so you simply run this in the background. So initiate this move operation. It's now moving. Even though this is a small disk, it takes a couple of seconds. But this can take up to hours, of course, or even days, depending on the size of the disk. And it's now, move is now complete. And then it should see a different mapping, which will do the mapping again, and then see where our data actually is living. So now it's finished. So let's map this thing again, logic volume display maps. And now you see this SDB1 is gone, and this is replaced by SDD1. We still have the other disk, of course, and we also have to move those PEs to the same disk, because remember the new disk is bigger, which can keep all the PEs. So let's move the other PEs as well. So I move the SDC1 PEs again to my new big disk. Again, the same operation. Takes a little bit. And if it's ready, we should see only one disk for our data. So it's finished successfully. Again, let's do this map operation. And now we see we have the entire blocks are now matched only to SDD1, to our new bigger disk. And of course our data is still in place, so nothing changed for the users. They still can work with this thing, so no downtime at all. Okay, so the last thing what remains to be done is remove the disk, or remove it from the volume group and remove the disk, and then we are ready and we have successfully replaced everything. So let's do the housekeeping job at the end. VG reduce, this simply reduces everything from a volume group 0, so we don't need SDB1 anymore. We also can remove SDC from the volume group. And then finally we can detach the disk entirely from our physical volume, and this is then done from PowerShell, because this is of course externally. We now have to unplug this thing. The command is a little bit more complicated than the add operation, because what we need to do is, first of all, we need to check about the hard drives, get VM hard disk drive, and the volume name is OPSIS. So this can bind parameter. VM can bind parameter. Get hard disk drive dash VM name OPSIS. Okay, so this gives us a list of the hard drives. And remember this disk 3, this was our big disk, and if I want to remove the first one and the second one. So in order to remove it, we need, this is an object from PowerShell, so we need to access this line first. So what we can do is the following command. We list all the objects and then we say, okay, where, and the path $. This is simply the selection of the correct path disk based on the path name equals. So when the path equals the first one, this gives us this object. The problem is, for removing disk we need to have the PowerShell objects and not the name only. So this gives us the first disk, and what we can do, we can assign this to a variable, to h equals this one, and then h contains this disk number 1, and then we can actually remove this thing, remove VM hard disk drive, and the name is VM hard disk drive is this H. So this then has removed the drive. So let's have a look at the disk. You see this now gone. This is one. This is now physically unplugging this from our machine. Let's unplug the other one as well. So we replace this with disk 2. Unplug this thing again. Oh, sorry, unplug again, remove this one with H, and now again it's gone. And now we see only have, this is our system disk from Multipass, and this is our bigger disk. And now when we go back to Linux, we should see that the disks are gone. Parted -L, you see it's not there anymore. STD, STB and SDC is gone, only we have SDA from the operating system and this bigger disk SDD. But again, the users are still working and are happy, and they didn't even notice about those change, and they go on working with the system. And this is one of the big advantages of the Logic Volume Manager, that you are quite flexible. You can enlarge disk, even resize, shrink it if possible. You can move it online and do all those interesting things. Okay, this was the second episode. This was the fourth episode. And on the last episode next time, then I will show you how to work with RAID arrays, because there's no redundancy yet. This is only a flexible operation with disks. And the question is, what happens if really we have a disk failure online? So even with LVM, of course, the data are gone because there are no redundancy. In order to overcome the problem when the disk completely fails, we use what's known as a RAID array. We will see in this next step.